This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on trigonometric equations. And the first one we're going to look at is 2 sine theta plus 1 equals 0. And there's an infinite number of solutions to this problem, but we just want to have those values that are going to be between 0 and 2 pi. So we're looking for values of theta that land within that first cycle, between 0 and 2 pi. To do this, we are going to isolate sine theta. So subtracting 1 from both sides, I get 2 sine theta is equal to -1. To solve for sine theta dividing by 2, we get sine theta is -1/2. We've got to think about the quadrants where sine is negative, and we've got to think about the reference angle. So the first question I'm going to ask is, where is sine negative? Looking at our 4 quadrants, the sine represents the y value. Sine is positive in quadrant 1 and 2, and it's negative in quadrants 3 and 4. So my answers will be in quadrants 3 and quadrants 4. Now what about the reference angle? We know that the sine of pi over 6 equals +1/2. That's our first quadrant answer. So the reference angle will indeed be pi over 6. Reference angle is always a quadrant 1 angle. But sine is negative in quadrants 3 and quadrants 4. So I need to think about where is pi over 6 in quadrant 3. So looking at our picture, pi over 6 measured from the x-axis in the third quadrant. Not quite to scale, because that should be 30 degrees beyond pi. So how am I going to get that? What's that going to represent? Theta will be pi plus pi over 6 more, which is 6 pi plus 1 pi, or 7 pi over 6. So that's our first answer. Now, sine is also negative in quadrant 4. So let's think where that would be. 30 degrees shy of 360. So again, that's supposed to be pi over 6. That's supposed to be 30 degrees in that fourth quadrant. So we're not quite pi over 6 to 2 pi, so our angle will be 2 pi minus pi over 6. And how do we do that? 2 pi times 6, 12 pi, minus 1 pi divided by 1 times 6 divided by 6. So that our answer will be 11 pi over 6. So we've gotten 2 answers. We put them in curly braces for set notation. My 2 answers are 7 pi over 6 and 11 pi over 6 for this first trigonometric equation. So let's see if we have another one here that's going to come up. We'll take a look at 4 sec theta plus 6 equals -2. And again, I want theta squeezed between 0 and 2 pi. We're looking for those answers because, again, there's an infinite number of solutions. We're going to isolate the 4 sec theta. Subtracting 6 from both sides gives me 4 sec theta equals -8, and then dividing by 4, we'll get that sec theta is -2. What do we recall about this? Well, sec and cosine are reciprocals. So the sec of theta is 1 over the cosine of theta. So if I take the reciprocal of both sides of this equation, the reciprocal of secant is cos theta. The reciprocal of -2 is -1 over 2. Well, we've got to think of the reference angle and the quadrants. So it looks like I'm doing the reference angle here first. We know the cosine of pi over 3 equals 1/2. So that's my first quadrant angle. That is my reference angle. Reference angle is pi over 3. But where is cosine negative? That's the next question I have to ask. So we think about our chart and we ask ourselves which quadrants are going to lead to a negative cosine. Cosine is the x values. So where is x going to be negative? It'll be negative in quadrant 2 and quadrant 3, because those would be negative x values. Quadrants 1 and 4 would have positive x values. So I'm going to need to find a quadrant 2 answer and a quadrant 3 answer, because cosine is negative in quadrants 2 and quadrant 3. So where is it in quadrant 2? Well, we'll draw it, And this time we're pi over 3 short of pi in quadrant 2. So if we're pi over 3 short of pi, that's going to give us pi minus pi over 3. 1 pi minus a third of pi, which is 2/3 of pi, or 2 pi over 3. Cosine is also negative in quadrant 3. So let's take a look at another picture there. Pi over 3 beyond pi. So what will theta be? Theta will be pi plus pi over 3. 3 pi plus 1 pi, 4 pi over 3. Getting our common denominator there. So we have our two answers. We have 2 pi over 3 and we have 4 pi over 3. Those are the only answers between 0 and 2 pi. Again, there are infinitely more, but those are the first two that we find between 0 and 2 pi. And let's take a look at one more question in this lesson. How about 2 sine squared theta minus 1 equals 0? And like the first two problems, we want theta to be between 0 and 2 pi. So we're going to isolate sine squared theta, adding 1 to both sides. 2 times sine squared theta equals 1. So sine squared theta is a half. Hitting both sides with the square root. Square root of sine squared theta is plus or minus square root of a half. So then sine theta is plus or minus 1 over root 2. What's nice about this is that will get us all 4 quadrants. But we'll solve it in pieces. We'll say sine of theta is 1 over root 2 in the first case. And then sine of theta is negative 1 over root 2 for the second case. What's our reference angle? Well, sine of pi over 4, 45 degrees, is 1 over root 2. So that's our reference angle. That's our quadrant 1 reference angle. And then we have to ask ourselves, in each case, where is sine positive and where is sine negative? Sine's the y values. Y values are positive in quadrant 1 and quadrant 2. So my quadrant 1 angle is just the reference angle. That's just pi over 4. No worries there. Quadrant 2, we are pi over 4 short of pi. So taking a quick look at the picture there, drawing that in, pi over 4, 45 degrees short of pi. That's pi minus pi over 4, which of course will give us 3 pi over 4. Now on the other side, we have sine of theta is negative 1 over root 2. Where is sine negative? Sine or y value, sine is negative in quadrants 3 and 4. In quadrant 3, we're starting at pi and then we're going beyond pi over 4. So looking at that, it's going to be pi plus pi over 4, which will be 5 pi over 4. Or 4 pi plus 1 pi over 4, which is indeed 5 pi over 4. And in the case of quadrant 4, what do we have? We are a little short. We're 2 pi, and then we go back up pi over 4. 2 pi minus pi over 4 would be 7 pi over 4. So we have 4 solutions between 0 and 2 pi. Pi over 4 is the first, then 3 pi over 4, then 5 pi over 4, and finally 7 pi over 4. And that will conclude this lesson.